Greetings, this is M squared. We're going to solve some linear systems by graphing. These are a little step up from the last one. Just real quick reminder, three things can happen when I solve a linear system, which means I'm finding out where two lines intersect. Either they intersect once, they're the same exact line, or they're parallel and they don't intersect at all. And sometimes the book asks you whether they're consistent and inconsistent, dependent, or independent. So keep that in mind as we go to solve these systems. The easiest way to graph a line is to get it in slope-intercept form, so that's what I'm going to do first. I'm going to take this equation right here, move 3x to the other side, and when I do that, then I need to get y alone by dividing by -6. So my slope-intercept form of this equation is the two negatives here cancel, 1/2 x minus 3. So my slope is 1/2. My y-intercept is -3. For this one, to get y alone, I'm going to move the 3 over here first, and then divide by 2. So I have 1/2 x minus 3/2 equals y. The slope here is 1/2. What I want you to notice is that the slopes are the same. So I know that this system is inconsistent. It has no solutions because when slopes of two lines are the same, they're parallel. So I still want to graph them because they told me to do it by graphing, but it's good to keep in mind that I know what's happening ahead of time in case I make a mistake here. So to graph this line, my y-intercept is -1.5 or -3/2, and my slope is 1/2. So I'm going to go up 1 over 2, up 1 over 2. When you have a y-intercept that's not exact at an integer, we've got a 0.5 here. You want to make sure that when you go up, you're going up 1, not 1.5. So that's kind of what that looks like. Down 1 over 2, and we're going to connect those dots. So that's that line. Now to graph this one, we know our y-intercept is -3. So we go down 3, and our slope is 1/2. So we go up 1 over 2, or down 1, left 2, and when we graph that, we see that there's no solution. So you just write no solution, or you could write inconsistent if they're asking you about that. Okay, next one. So this one, you notice, doesn't have a y, so we can't get it into slope-intercept form. I mean, we can't get y alone if there's no y. Hopefully you remember that this is a vertical line. Lines that just have x are vertical, lines that just have y are horizontal. So let's just graph that real quick. So we'd go left 4, and all along this line x is -4 because I'm 4 to the left. So y changes, like this is -4, 3, this is -4, 0, this is -4, -4. So all along this line, x is -4. That's why we call it x equals -4. To graph this one, let's get it in slope-intercept form first. So we're going to divide by 2, and we get y equals -6 minus 2x. So our slope is -2, and our intercept, our y-intercept, is -6. So I'm going to go down 6, and then I'm going to go up 2, left 1, because my slope is negative, so I want it to go down, from left to right. So right there is my solution. So these are going to intersect at one spot, so we'll have one solution, and the solution is -4, 2. So to check this, it's easy to check on this one because x is -4, and that's what it says. Over here, we'd put a -4 in. -4 times -4 is positive 16, and 16 minus 12 is 4, and then 2, we put the 2 over here. Yeah, it's 4 on this side, sorry. And then 2 times 2 when we put the y in there is 4. So 4 equals 4, we know we're right. And so this one is called consistent and independent because it has one solution. Good luck. M squared, signing out.